Hey guys, how's it going? Welcome back to another week. This week we're gonna be talking about something new, so get ready. Here we go. All right guys, so this week we're going to be talking about finding the volume. That's kind of our big idea for this week. Time to talk about a word called volume, okay? So I want you to think of volume as the amount of space that a 3D object occupies. Notice I said a 3D object occupies. So the amount of space that a 3D object occupies. Before we get really deep into volume this week, let's kind of take it a step back and kind of talk about what we've been up to. So last week we talked about a different type of space, the area of something. Remember, we've been talking about the area of circles, the area of squares, the area of triangles, you know, things like that. So we've been talking about the word area a lot. So when we talk about area, you know, it's the space. Area is a space that a 2D object occupies. So I want you to think of 2D objects like we have been talking about, like the space inside of this square, the space inside of this triangle, the space inside of what else? What are some other shapes we've talked about? Of a circle, right? I want you to think of shapes like that. Maybe even a rectangle, right? The space that's inside of that. So we've been talking a lot about that word, area. But this week, we're gonna move on to, instead of 2D shapes, we're moving on to the space that a 3D shape occupies. And I want you to think of the 3 dimensions as basically the 3 sides or the 3 like numbers that we're gonna be working with when it comes to volume. So area and volume have that one thing in common. You might wanna remember this for the challenge this week. Volume and area are both about the amount of space that something occupies, the space. But they're different because volume is about 3D figures, okay? And area is about 2D figures. So what are some 3D figures that you guys might be familiar with? In 6th grade, I want you to think of maybe something like this. Let me just try to draw it real quick. Let's talk about this shape right here. And I want to see if you guys can remember what this might be called. Oof, kind of hard to draw today. Let's see if I can make this look good. All right, so this is a type of shape. I know it doesn't really make a lot of sense right now, but it's a 3D shape. We have basically rectangles all the way around, and we have these bases right here, these things back here on the front end and the back end. This is called a prism. In fact, this is called a rectangular prism. Today, we're gonna be talking a lot about volume, but specifically the volume of things called prisms, okay? Volume of a prism. So this is called a rectangular prism. Okay. What do you think this might be called? Let me try to draw this one out for you. Ugh, my drawing skills are pretty bad today, guys. Okay, so let me try to fix that a little bit. Okay, there we go. If that was called a rectangular prism, what do you think that one's called? You guys are so smart. Triangular prism. Okay. And there's one more kind of prism that we're gonna talk about today, and it looks kind of like this. Any idea what kind of prism that is? If you said circular prism, you are wrong. Sorry guys. In math, for whatever reason, we call these a cylinder. Everybody say cylinder. I wish it was called a circular prism or a circle prism or something so that it would make more sense. But in math, we call these a cylinder. Now, notice some similarities and some differences between these shapes. Take a look. A rectangular prism has some 2D shapes on there that look kind of like this. Triangular prism has some 2D shapes on there that look kind of like this. Cylinders have this shape on here as well. Here is why. I want you to think of volume as sort of a 2D shape that kind of gets stretched out, okay? So let me kind of bring you from area to see how it is basically volume. I want you to take a very, very close look at this. Okay, so do you see these shapes? What I'm gonna do is I'm gonna stretch them out so that you can see that you can make a 2D shape into a 3D shape. So for example, if I have this square, let me redraw it right here. Okay, there's my square. This is called the base of my 3D shape. And what I can do is if I stretch this shape across and I stretch this square in this direction over here, okay? This space that it got stretched is basically a dimension, okay? This is the height of that shape. Notice every shape has a length and a width, just like we talk about with area. Well, here's the length, here's the width. But it also has a height, which is how much it got stretched in that direction, okay? So we're starting to move away from area into now what's called volume, all right? So I hope that kind of makes sense. I'm gonna go ahead and try again with a different shape. So here's the triangle. So check this out. I'm gonna draw a triangle. And what am I gonna do? I'm gonna stretch it, right? So remember, the triangle has a length and a width as well, or like a base and a height, I guess you would call it. Remember we talked about area of triangles being the height and the base, or the length and the width of a triangle. Well, I'm gonna stretch the triangle across all the way so that you can see the other side of it. Here's the triangle again, over here, stretched across. And all this that it got stretched is going to be considered the height again, the h. Notice that similarity between these two. Guys, same thing goes for all these shapes that you see here. Think about this circle. If I had a circle up here, okay, and I wanted to stretch that circle down like that, and I wanted to end up with the circle down here, well, the amount that I stretched it, the amount that I stretched that circle from right here to right here would be called the height, okay? Would be called the height. Hope that kind of makes sense. So you're probably wondering, Mr. Dillon, what's the point of this? What are you trying to tell us with all this information, mister? Why do we need to know this? Well, here's why. When you were in elementary school, maybe you learned this formula. To find the volume of a 3D shape, you need to do the length times width times height. So yay, it was super easy. And so you had maybe something like this, maybe a rectangular prism, and it was so much fun because you already knew, okay, the length is 5, the width is 6, and the height is 2. So mister, length is 5, so I'm gonna put 5 times the width, 6, so I'm gonna put 6, and the height is 2. So super easy. 5 times 6 is 30, and then 30 times 2 is 60. Mister, the volume is 60. Yay! Awesome. But guys, this formula right here, I hate that formula, guys, because it only works for this shape. But in math, there's so many other shapes than just that. For example, if I gave you this shape, let me zoom out a little, let me just move this over here. If I gave you this shape right here, the cylinder that we just talked about, now this isn't something that you can find by just doing length times width times height. All right, what's the length of this? If I said this was 5 and this was 3, Okay, cool. That's the height. I think that's the length. How would I find the width of this? What do I do? Exactly. Because this formula is not very clear about how to find the volume of a shape like this. So I want you to forget everything that you know about this formula. Length times width times height, erase it from your memory. Erase it, erase it, erase it, erase it. Okay, is it erased? Awesome. So now that it's erased out of your memory, I'm gonna introduce to you the magical volume formula that you guys are gonna need to be able to find the volume of any prism. Notice I said prism because there's more than just prisms, but for this week, any prism. So to find the volume of a prism, all you need to know is this. That's it. Got it? Okay, cool. Class dismissed. See you guys next week. Bye. See you later, guys. Just kidding. All right, so there's more to it, guys. Now, what does this even mean? Mr. Dillon, how are you gonna leave us hanging like this? We don't even know what these letters stand for. All right, V stands for volume. B stands for not what you're thinking, not the base. B stands for area of the base. It's very important. And H stands for height. You probably already knew that one. V stands for volume. B stands for area of the base. This is gonna get super important later. And H stands for height. Now, if I wanted B to stand for just base, I would put a lowercase b, like this. But that's not what I put there. I put a capital B. So it's very important you don't get that confused. Big B stands for the area of the base. So to find the volume of a prism, this is all you need. You need to know the area of the base and the height. Now, those letters are next to each other, and when they're next to each other, you guys kind of should already know, but I'm just gonna remind you, they're multiplying, okay? That's what that means. You're multiplying these two letters together. So next what I'm gonna do is I'm gonna go over how to find the volume of a couple of shapes, all right? So hopefully that way you kind of have a better idea of how to do this. We're gonna find the volume of a prism, rectangular prism, of a triangular prism, and a cylinder, these three. And if we can get through these three, then I think you'll be ready for this week's challenge, okay? So let's go ahead and get started. Let's start with this one right here. So here is our first shape, a rectangular prism. Remember what I said? To find the volume, you're gonna do the area of the base times the height. But Mr. De Leon, how do I find out what the area of the base is right here? Okay, first of all, since it's a rectangular prism, we're gonna break this down. So I'm gonna cover this for a second and remind you about something. Remember, a rectangular prism is a 2D shape that is stretched across. Remember that? So we have our square, our base right here. This is gonna be considered our base. So guess what? We're gonna find the area of that base. And then after that, let me stretch it across. Let me see if I can draw this. I'm having so much trouble drawing today. Okay, and stretching across. So we have to find the area, the area of the base, the area of that base, probably tired of me saying area today. And we're gonna find out how much it was stretched across. That's the height. Remember? We talked about that earlier in the video. H. So the area of this base is where? Would it be this? Would it be this? Would it be all the way back there? Would it be that part that I just finished shading, the part that I called the area of the base? If you think this is the area of the base, you are correct. That is the area of the base. Hold on, this is my OCD. I have to make sure I shade all of this in. There we go. All right, let me make sure I get everything. All right, perfect. That is the area of the base. So, Mr. De Leon, you haven't told us any numbers. All right, let's put some numbers down. Let's put a 5 right here. Let's put a 6 right here and a 2 right here, like the other numbers before. All right, how would we find the area of this base? Well, What shape is that? Okay, it looks like a little rectangle. We have 6 times 2. So what's the area of that base? So let's go ahead and write this formula down here. V equals big B times H. All right, the area of the base is, what's 6 times 2, y'all? 12. Awesome. And now we just need to multiply how much this got stretched. What is the height, or how much this was stretched across? This square, how much was it stretched across this way? How many dimensions? Hint, hint, hint. How many units? 5 units. So guess what? We're gonna multiply the area of that base times 5. 12 times 5, guys. And that is how you find the volume. The volume, what is 12 times 5? 12 times 5 is 60. Okay, let's say that this was in inches. Why not? Let's just put inches right here. So the volume of this rectangular prism is 60 inches cubed. What? Cubed? Yes, cubed. The reason we use this 3 is because why? What do you think we use the 3 for? Is this a 2D shape or is this a 3D shape? That is right, guys. This is a 3D shape. It has 3 dimensions, not 2. Kind of like the 3 stars on this Dragon Ball, okay? It has 3 instead of 2 dimensions. We have the length, the width, and the height, okay? So that is how you find the volume of a rectangular prism. Capiche? Go ahead and rewind it if you don't understand it. All right, next. Okay, next shape, everybody's favorite. What's this one called again? Anybody remember? Yep, that's what it is. I hope you said it right. This is a triangular prism. Triangular prism. Why do you think it's called triangular prism? What's up with that? What's the shape of the base? Ah, a triangle. Interesting. It sounds like the name of the shape gives away what the base is gonna be, doesn't it? Triangular prism, then the base is a triangle. Rectangular prism, then the base is a rectangle, okay? So hopefully that you're starting to make that connection. So let's put some numbers on here. We're gonna put let's put a 5 right here. We'll put 5 inches. This will be, let's put 10 inches. And then over here, we'll just put 6 inches. How about that? Okay? So I hope that makes sense. All right, Mr. Leon, how do I find the volume of this kind of shape? Guess what, guys? Same formula for a whole nother shape. To find the volume, you need to find B, big B, which means the area of the base, okay? So the area of the base. Now, what did we just say the base was? Was it this or was it this? Hint, hint, hint. Ah, the base is right there. So we're gonna find the area of that little triangle right there first. So V, which is volume, stands for the area of the base. We're gonna put a number there in a bit. We don't know what that is yet. Times the height, okay? We're gonna put a number in there. Now, I think we know what the height is already. Remember we just said it's the base and how much it was stretched that way. So how much was this triangle stretched in that direction? What do you notice? How many inches was this triangle right here? This triangle right here. How many inches was this triangle stretched across that way? Exactly, 6 inches. So the height is 6. The only thing we need to really kind of figure out is how do you find this, the big B? Okay, one more time. Big B stands for area of the base. So guess what? All you have to do is find the area of a triangle. Now, if you don't know the area of a triangle, you might want to refresh your memory a bit. We talked about it, I think 2 weeks ago. The area of a triangle is the base times the height divided by 2. Remember? So the base times height divided by 2. So here's the base of the triangle, which is 5. So instead of a B, I'm going to put 5. instead of putting an h for height of this triangle, the height of this triangle is 10. So 5 times 10 divided by 2. So there we go. The area of a triangle is 5 times 10 divided by 2. 5, the base, 10, the height, base times height, divided by 2. All right, and let's go ahead and find the area. What's 5 times 10? Oh, come on, that's pretty easy. 5 times 10 is 50. And then what's half of 50? What's half of 50 cents? 25 cents. So half of 50 is 25. So guess what I'm gonna put right there? Boom. That is the area of our triangle, right? 25 inches squared, because it's the base times height divided by 2. There we go. So now what's left? We just plug it in, we just multiply 25 times 6, okay? And we're gonna get our answer. So let's do it on the side. 25 times 6, let's see what we get. 6 times 5 is 30, carry my 3. Boom, 150. So the volume of this triangle is 150 inches cubed. Why is it cubed? Because it's 3D. 3D. Remember? 3. 3, 3, 3. Not 2, like this one over here. Not 2, but 3. Okay? All right, guys. That is how you find the volume of a triangular prism. Hopefully that makes sense. Go ahead and pause it or rewind it if you need help. We got one more to go. Alrighty, guys. Don't be scared. This is just the final one. We're almost there. I know it looks a little hard because of the whole circle thing going on up here, but don't worry. It's gonna be fine. I got you. Look, here's what you do. Volume of a cylinder. Let's talk about that shape. The cylinder. The cylinder looks scary to a lot of people because it has like no edges. It doesn't really look as clear and cut and defined as maybe something like this or something like the one that we just did with the triangles. But it doesn't mean that we can't do it because the formula is always there and we always know we can use it for this because it's a type of prism. Except in this case, we're dealing with this base right here. Instead of it being a rectangle or a triangle or something like that, it's a different shape, right? It's a circle. Why do you think we learned about circles last week? Because I was getting you ready for something like this, right? So hopefully last week you've done the weekly challenge and you understand how to find the area of a circle because you're gonna need it to get through this, all right? So volume equals the area of the base times the height, all right? For the height, let's just say the height of this cylinder is, I'll just put a number, let's put 5 inches, okay? So height is the easiest one to plug in. I'm just gonna put a 5 there because that's the height. But for the area of the base, think about it. This is in the shape of a what again? Of a circle. So we have to use the formula for the area of a circle. Oh boy. Area of a circle, if you remember, hopefully is pi times radius squared. That's what we're gonna do to figure this out. Pi times radius squared. Okay, so let me give you guys the dimensions for the circle. I promise it's not gonna be too crazy. I'm gonna maybe give you the diameter just to kind of trick you, right? I'll say, hey guys, the diameter of this circle all the way across is gonna be 10 inches, okay? So does that mean for the area of a circle, you're gonna go and put 3.14 times 10 squared? Is that the radius? No, that's the diameter. So be careful. You're not gonna put a 10 because we learned last week that the radius is not 10, it's what? 3.14 times 5 squared. Why is it 5 and not 10? Because the radius is half of the diameter, remember? So we're gonna basically find the halfway point between the middle to the outer edge. So there we go, 3.14 times 5 squared. So that means we're gonna do 3.14 times, what's 5 times 5? 3.14 times 25, okay? Let's go ahead and calculate that real quick. 3.14 times 25, let me know what you get. I'll pause the video for a bit. All right, when I multiplied this out, I got an area for the circle of 78.5 or 78.50 inches squared, okay? So that is how you find the area of the circle. Just a little review, okay? So guess what? Big B, the area of this base is 78.5. Capiche? 78.5 or 78.50. I don't know how you guys got that answer, but that's basically what you get. Okay. And now the last step is to multiply the area of the base, the big B, times your height. All you have to do is multiply these two. So to find the volume, you multiply this times this, and you get, let me just fast forward, speed through this, you get 392.5 or 0.50. Since we're talking about inches, we're gonna say inches cubed, inches cubed. One more time, why am I using cubed? Why is it a cubed dimension and not a squared? Because it's 3D. These shapes are 3D shapes, not 2D shapes. They're 3D shapes, not 2D shapes, okay? Awesome. So there we go, guys. That is how you find the volume of a cylinder. All right, guys, so before I go ahead and close the video and show you this week's challenge, I want to review with you one more time. Volume, like we said, is the amount of space that a 3D object occupies. How do you find the volume is basically, and by the way, we're focusing on prisms, okay? So we're finding the volume of prisms so far. To find the volume of a prism, you need to imagine it as a 2D shape that is being stretched across that third dimension. So we have basically this being stretched, this right here being stretched, this and this, for example, this one being stretched, and that's your height. That's your third dimension that you're adding on. And to find the volume, remember, is very simple. You just need to know the area of the base. I'll put that one more time. Area of base, and you're gonna multiply the area of the base times the height. Remember, we completely forgot about this formula. Okay? Completely erased out of our memory. That is gone. Now we're using this formula to find the volume of shapes that are 3D, okay? H stands for height, by the way. All right, so there you go, guys. That was this week's lesson. Coming up next is your challenge for this week. So here we go. Alrighty, guys. So it took a little time to draw these out a little bit more carefully so that it made more sense. But here is challenge number 6. I hope that you're able to solve these 3 questions for the challenge. So basically for this week's challenge is what I want to know is, can you find the volume, okay? Can you find the volume of these 3 shapes? That one, and that one over there, okay? So we have a rectangular prism, we have a triangular prism, and we have a circular prism. Just kidding, a cylinder, okay? So we have these 3 shapes. Remember, to find the volume, you're gonna need that special new formula, the area of the base times the height. The area of the base times the height. Remember, you're gonna have to find the area of this times how much it was stretched out, the area of this times how much it was stretched out, and the area of this times how much it was stretched out. So let me know if you have any questions in the comments or in Google Classroom, and I'll be more than happy to help you. If not, then good luck. There's going to be more than just 3 questions. I'm gonna have a couple more questions about some other things, so make sure that you answer those as well. So good luck, guys, and stay tuned. I'll see you guys maybe sometime later next week. All right, bye-bye. All right, guys, last thing before I close, I forgot to mention, make sure you're turning in your assignments in on time. I'm constantly updating with your grades and making sure everything's put in on time. So please make sure if there's anything late or that you haven't submitted, you're getting that stuff turned into me on time. Again, one more time, another reminder, it's probably the last time I'm gonna remind you. if there was a grade on an assignment that you didn't like or that you wish you had a better grade on, do it again. We can redo it and I can give you a better grade for it. So go ahead and do that, and good luck with the challenge. I hope you guys are able to do this, okay? Good luck with it. Make sure that you guys kind of go through it. And other than that, have a great week. Do some math practice on the daily, and enjoy the rest of your week, guys. I'll see y'all later. Bye. Miss y'all.